we are having a transparent glass of water, and if you see it from downside to upside, sometimes it happens that the upper surface of that water, it seems to be silvery, seems to be shiny. Why it happens? Have you ever wondered to know that why it is happening? Today we are going to discuss about the same topic. That our topic is total internal reflection. My name is Suram and I welcome you all to my channel. So our today's topic is of the same chapter, that is the refraction of light of standard 10, total internal reflection, and in short it is also known as TIR. In short we are saying it TIR, total internal reflection. As I was telling you that when we are holding the glass of water above your eye level, then if you see it from downside, the upper surface seems to be silvery sometimes, certain angle. You're knowing the critical angle. We'll discuss about the critical angle. What is critical angle actually? So let's see. Suppose this is not a glass of water actually. Let it is a tub, water, transparent tub. And inside this tub we are having any object, any coin is there, suppose O. The ray of light which is traveling from this coin straight to an angle 90, it will go straight, right? If it is fall at 90 on the surface, it will pass straight. There will not be any refraction. And if the ray of light is traveling at certain angle, here you can see the angle point of incidence, and this will be the normal line. So here the refraction will take place. Refraction will take place. This is angle I and this will be R. Same way, if we go on increasing the angle of incidence, this line, this is the normal line again, and this will be the refraction. So if we go on increasing the angle of incidence will increase. In this case, the angle of refraction will also increase. The stage will reach when the angle of incidence and the angle of incidence, then the ray of light get refracted along the surface of water like this. The angle of refraction is also increasing now. The stage will reach when the angle of refraction will be 90 like this. Means light ray will get refracted along the surface like this. Ray of light is going like this, the angle of refraction. So in this case, this angle I is actually the IC angle. This angle here is now IC. This is noted sometimes with C also, or it is noted with IC. That is called the critical angle. It is actually called the critical angle. Critical angle, let's understood what is critical angle first. Critical angle is the angle of incidence. This is actually the angle of incidence, is it? Because light is going from denser to rare medium. The water, so this is denser medium, and light rays passing from water to air. Here is the rare medium, is it? Here is the rare medium. The light rays traveling from denser to rare medium. So it is the angle of incidence in the, what is the critical angle? Angle of incidence in the denser medium, corresponding to which the angle of refraction in rare medium is 90 degree. What is the critical angle? Critical angle is the angle of incidence in the denser medium. This is the denser medium, water, corresponding to which the angle of refraction in the rare medium is 90 degree. This is the critical angle, right? Critical angle for glass is 42 degree actually. Critical angle for glass is 42. And for water is this 48, right? 48 degree. And for diamond it is 24 degree. right? These are the values of critical angles. So here this angle is the angle of critical angle of incidence. So if this angle is increased, means if we further increase this angle, then at this point you will see the light ray will not get refracted. Here the light ray will not get refracted, but it will get reflected back into the same medium. At this point we go on increasing further, angle of incidence become more than the critical angle. Angle of incidence in this last case, angle of incidence is greater than critical angle. Angle I is greater than angle C. Angle I is greater than angle C, that is the critical angle. The angle of incidence is greater than the critical angle, is it? Then light ray will get reflected back into the same medium. The light will not go out, it will pass into it will get reflected back into the same medium. So this is the case of total internal reflection, called the TIR. Called the TIR, total internal reflection, right? So here you can see total internal reflection. It is the phenomena due to which a ray of light, while traveling from optically denser medium to the optically rarer medium, gets reflected back into the optically denser medium at the surface of separation. The surface of separation is called total internal reflection. Is it? Called the total internal reflection. The critical angle that we have discussed already. Critical angle, it is the angle of incidence in the denser medium, corresponding to which the angle of refraction in the rare medium is 90 degrees. What are the conditions for TIR? Conditions for TIR, that is very important. Conditions for TIR. All these three things are very important. Whether it is the definition of TIR, whether it is critical angle, whether it is the conditions for the TIR. The very first condition is the rays of light must travel from optically denser medium to optically rare medium. There you can see the rays are traveling actually from denser to rare. It will not happen for the rays of light are traveling from rare to denser. It will happen for denser to rare only. That is the important thing that you have to remember. First condition. Second condition is, first thing is rays must travel from denser to rare. Denser to rare. And second thing is the angle of incidence, angle I, must be greater than critical angle. These are the two conditions. If these two conditions are satisfied, only then the TIR will take place. Otherwise, there will not total internal reflection take place. Is it? The total internal reflection, very important. Again, I am telling. So conditions, critical angle. So in next video we will discuss about the relation between refractive index and the critical angle.